Here's a level 3 problem from your text. An object starts off with an initial velocity in the horizontal direction. So the object is moving in the horizontal direction with an initial velocity v0. What we want to know is at clock time t, what's the magnitude and angle of the velocity? Now the text phrases this as derive an expression for the magnitude and angle. Actually, I think it's just for the angle of the velocity at clock time t, if it starts at t equals 0 with velocity, horizontal velocity v0. Well, this isn't hard. The x velocity is always going to be the same, v0. Now, it's not easy, but in light of what we've just been through, it's not hard. So the x velocity is v0. What's the y velocity? Well, we know how long it's been falling. Our delta t is just the clock time t. So that the y velocity is just going to be the product of acceleration and delta t. That's actually a change in y, but the y velocity started out at 0, so the y velocity is going to equal the change in velocity, a delta t. Acceleration is negative g, so that the y velocity is negative gt at this point. So now we see that the velocity is a vector with components v0 in this direction and vy in this direction. What's the angle? Well, it's the arctangent of the y component over the x component. Arctangent of negative gt over v0.